In this video we'll look at problems 27 and 28, which could be handled as quotient rules but might be more easily handled as product rules with a simple rewrite. So we'll rewrite 27 as x, then times x squared plus 1 to the negative 1/2 power. And we'll begin to find y prime then. It'll be the first times the derivative of the second, and with the second we'll get negative 1/2, and just make sure you note that that's not minus 1/2, it's times negative 1/2. Leave the inside alone, x squared plus 1 to the negative 3/2 power. Then times the derivative of the inside. So we took the derivative of the outside, leave the inside alone, times the derivative of the inside, which is 2x. Then plus 2, the second function, x squared plus 1 to the negative 1/2 times the derivative of the first function, which is just 1. And we're ready to begin rewriting. Alright, and the term on the left, we have a 2 in the numerator, 2 in the denominator, that will cancel there. The x's will multiply together and we'll get x squared, but since that's times negative 1 still, we still have to keep the negative sign in there. So negative x squared. Then times x squared plus 1 to the negative 3/2 and plus x squared plus 1 to the negative 1/2. Again, we're going to factor out the greatest common factor, which will be the most negative exponent. And so that'll be x squared plus 1 to the negative 3/2 power, leaving behind negative x squared and then plus x squared plus 1 to the 2/2, because negative 3/2 plus 2/2 gives you negative 1/2, and so that's just to the first power. And fortunately, when we go to simplify that, the negative x squared and the positive x squared will zero out, and we'll simply end up with 1 over x squared plus 1 quantity to the 3/2 power. So it simplifies pretty well. You just have to really be careful with all the details in the arithmetic and the algebra there. And we'll go on to problem 28. Well, 28 similarly can be rewritten as x times x to the 4th plus 4 raised to the negative 1/2 power. And so the derivative will be y prime, and it's the first times the derivative of the second, same type of situation as in problem 27. So it's x times negative 1/2, then we're going to reduce the exponent by 1 to get negative 3/2, leave the inside alone, x to the 4th plus 4, then times the derivative of the inside, which would be 4x to the 3rd. So that's the 1 d2, the first times the derivative of the second, then we have the second plus the second function times the derivative of the first, which is just 1 again, and we're ready to start simplifying here. So we have a 2 in the denominator, a 4 in the numerator, so that'll simplify to just a 2. Then we have x and x to the 3rd, so it'll be 2x to the 4th. Only it's negative, you have to watch out for that. Then that is times x to the 4th plus 4 to the negative 3/2 power. Then it's plus x to the 4th plus 4 to the negative 1/2 power. We're going to factor out the greatest common factor, and so that'll be x to the 4th plus 4 to the negative 3/2, and that leaves negative 2x to the 4th, then plus x to the 4th plus 4, but that'll be to the 2/2 power, negative 3 over 2 plus 2 halves is equal to negative 1/2, and 2 halves is just 1. So that's the really cool thing about factoring out that greatest common factor. It's going to make those exponents go away there. So finally you have x to the 4th plus 4 to the negative 3/2. Then negative 2x to the 4th plus x to the 4th is negative x to the 4th, or 4 minus x to the 4th. And 4 minus x to the 4th can be broken down into 2 plus x squared, 2 minus x squared. I'm not sure if this is really worth it to keep working on that. The 2 minus x squared can still be broken down into square root of 2 plus x, square root of 2 minus x. But I think we'll leave it at 4 minus x squared over x to the 4th plus 4 to the 3/2 power. And that does it for number 28 and for this section.